So property of AI given B is equal property of AI and B divide property of B. We know that AI and B is a property of AI multiply property of B given AI is the definition of conditional probability, and this we use total probability as this formula. This formula is called Bayes rule. Is very simple but has a lot of application in computer science, machine learning, and AI, artificial intelligence. The Bayes rule and inference is invented by Thomas Bayes from this time. For Thomas Bayes is systematic approach for incorporating for new evidence. The Bayes inference is beginning with initial beliefs P property of AI on possible case of an observed event B. It models the world of under its AI or property of B given AI. So we had two is a model. We have AI is the AI for its AI is the initial belief. We model for property of B by B given A, and we draw conclusions about the causes by inference. We have property. How about property of I given B is the BI given B? It's the role of Bayes rule for so very important. Here is a model based on conditional probabilities. For example, we had 3 toss of a Bayes coin BX equal B, B head a property of head AB and property of tail A1 subtract of B. Here 3 tosses. First B, second is head, tail, head, 1, 2, head 3. So the multiplication rule, property of T, tail, head, tail, it means that here we multiply all this is a 1 B this part and 1 B square. The total property of one head we have here, one head, and one head is this B, this, and this. So 3 left multiply with each of these is a 1 minus B square multiply of B. The Bayes rule is property of first toss is given as 1 head. First toss head is just only this, and so we can easily know that it's 1 toss. So how to calculate the property of first toss x1 and 1 has divide property of 1 has and this event I first one a head and just only one head, so here just only this, so this a b multiplies minus 1 minus b square, and this for one head we calculate here is 3 b multiply with 1 b square, and here is the 1/3. So independence of two events, independence. Here introduce definition property of B given A is equal property of B. It means that the knowledge of A does not affect to property of knowledge of B. So occurrence of A provide no information about B. So it define of independence if property of A and B equal property of A and B. From previous slide we know this is property of A multiply property of B given A. Since it is independent, so property B given A is equal property of B, so we have this formula. So this formula has symmetries with respect to A and B. It means that property of B intersects with A has the same, and imply a property of A given B also equal property of A, means that A and B independent. It applies even if property of A equals 0. So here we have two events A and B, property of A greater than 0, B greater than 0. So is this A and B independent? Here we saw that A and B is disjoint. It means that there are no elements that's the same for A and B. It is totally disjoint. So we have property of A and B equal 0, since it is disjoint. Property of A multiply property of B is greater than 0, since A greater than 0, B greater than 0. So we can conclude that there is no independent, since it violates this definition. So here we can saw that the totally different between the choice or disjoint event with dependent or independent. The disjoint event not means that it is independent. So independent of event of complements. Here we have definition of independence, property A and B equals this. So if A and B are independent, then A and B complement also independent. Why? Here we have A and B, A, B. This part is A intersects with B. Here we have A equal A intersects with B union A intersects with B complement. It means that this part is A intersects with B complement. So here since the probability of A equals this probability of this. Two events here it is totally destroyed, so it equals probability of A and B plus probability of A and B complement. We can move this bar to this side. It's equal B A minus probability. Since it's independence, it's probability of A multiply probability of B equal probability of A and B complement. This is equal B A multiplies 1 minus probability of B equal B A and B. 1 minus probability of B is a probability of B complement. So we can write to probability of B complement is this matrix. So complement, this formula means that A and B complement are independent. The next is we consider about conditional independencies. Conditional independence given C is defined as independence under the property of laws. Any event given C, for example here we have A and B and given C, is A and B independent? We assume that A and B are independent. If we thought that C occur, it means that A and B are independent again. We see that C occurs, so sample space just only this sample space here. Since two sample space are destroyed, so it means that if this occur, this will not occur, this occur, this will not occur. So we can conclude that A and B not independent, because if A occur, B not occur, with the condition that C occurs. So this is no. The conditions might affect the independence. Here we have two unfair coils, A and B. Probability of H in coil A is 0.9, but in coil B, probability of H is just 0.1. It is two unfair coils. Two is coil with equal probability. It means that probability of each two is 1/2. We can choose coil A or coil B is same. Here we have 50-50% for each ZA for coil A and ZA for coil B. The probability of head or tail for each coil is for each time of toss is independent, but here we compare probability of toss 11 is head. If we apply a total probability of A multiply probability of H head 11 given at A plus probability of B. Here total probability of H 11 given B. So this is equal 1.5 multiplies, because independent as shows the probability of 11 toss head also same here, con A 0.9 sorry, plus here is E 0.5 multiply 0.1. So how about property of the 11 toss A hat? As given the first tosses are hat, you can apply the pair rule for this, but here we can know that on the 10 tosses are heads, so it means that the higher probability that is con A. So this is equal probability of heads given A. So it's E 0.9. Here I will come back one conditional property. Here probability of A and B given C is independent with property C, so it's equal probability of A given C multiply probability of B given C. The probability of conditional independence, A and B independent with C. Here is condition affects the independence. Here A can be independent, but the condition that we saw 11 toss A had given that on the first 10 toss I had the condition, and it affects that the net 11 also has seen it choose con A, so it affects independence. The independence of a collection of events, the intuitive definition, information of some of the events does not change the probability related to the remaining events. Here we define event A1 to AN are con independent if probability of on intersection equal multiply of its probability for any distinct indices. Here for concrete example we had 3 event A1, A2, A3 and its sum independent, so it's a pairwise independence, and from pairwise independence we can calculate this is a collection independence easy by divide A1 and A2 in one group and intersect with A3. So divide in this the collection of event independent independent. Here sample of independence with pairwise independence. Here we have 2 independent pair of coils. Here pair coil, so its head or tail is 1.5. First top A head and second top A head. Property of this head is 1.5. So C is 2 top has the same result. We can raise it as head, tail, tail, head, and tail. We have 4 events in this sample space. C is the 2 talk has same result as head or tail. Here. C here, sample space for C. X1, S2, and C pairwise independence but not independence. How to prove it? The sample property of X1 and C equal the first talk A head and same is he just only one event here. Is the 1.5 C sorry 1.4. Why? Because the first A has C is the event that the same result, so is equal with probability of first A has and second A has is equal 1.4. Sorry here 1.5. 1.5 is equal 1.4. And probability of X1 multiply probability of C is equal 1/2 multiply 1/2. Why C 1/2? Because it has 2 events for sample space 4 is a 1/4. So the equals, so it means that the first talk A had and the event C is a independence. The same for second talk A has and C. So as first talk C had 2, C is a independent. Or better said that is a pairwise independence, but is it 3 event independence? So let's consider probability of the first talk A has, second A has, and C. It means that just only one event here, so it's a 1/4. But probability of has 1, probability of has 2, and multiply with probability of C equal 1/2 multiply 1/2 multiply 1/2 is equal 1/8. It's totally different with this 1/4. Therefore, X1, X2, and C are not independent. So, independence not means pairwise independence. How about conditional independence? Let's clean it. Conditional independent property of C given H1. It means that property of the second top A hat given the first top A hat, it has the same result. So here is equal property of H2 has second thing, H1 and H2 are independent, so it's E1 plus a half, and it's equal property of C. So means that C, H1, H2 are pairwise independent. How about property of C given H1 and H2? It means 2 seconds has is a property of H1 multiply property of H2. 2 times S is E1 4 and E different with property of C. So this means that if we combine two events S1 and S2, two top has, it will not independent with C. The reliability, some example for apply is we have properties Pi that units I is up. So all Pi is independent units. Here we have the serial connection. So what is property is E up? Up it means that property of icon is the unit 1, unit 2 and unit 3. So it's up with 3 of them is up, so it's over unit 1 up and unit 2 up and unit 3 and since 3 units are independent, so it's equal property of unit 1 multiply unit 2 multiply unit 3. So it's a P1 multiply P2 multiply P3. If property that system is up. How about in the parallel structure? It's up when one of units is up, or we can consider an inverse problem when it is failed. If failed 1, 3, both of them if failed, it means that here fail probability of unit 1 fail and unit 2 fail and unit 3 fail, and probability of E up is E minus and minus 1 minus B1 multiply 1 minus b2 multiply 1 minus b3. You can see that this value is greater than a lot of time compared with this value. So the property in this structure is better than, greater than this structure, and is a more reliability. Here's a final example that's all about conditional probability. It is citing some of named king sibling. The king come from a family of 2 children, exactly 2 children. What's the probability that his sibling a female? Sibling a female. We had some assumption here, but it's 2 children, and the probability of boy and girl is same, is 1/2. Only boy or girl, not third gender. So here we have some boy, girl, boy, and girl. We have 4 event in sample space here. And what's the probability of his sibling a female? It means the probability of girl given than boy. We can use probability of girl and boy divide probability of boy. The pair truth. This is a 1/2 multiply I'm sorry, he's some confused. Let's erase this. Here each property is 1 4 1 4 1 4 1 4 from nature. We have the probability of a female is 1/2. Is this right? But in this case, it's a king family, so it must have 2. So the probability of king, a boy, is a 3 1 4. Is the probability of boy. So I'm sorry here. The probability of his sibling a female, it means that 2k here, 2k here. In conditions that the king, so it's just 2 3 is a girl. So we can see that his sibling a female is the property of boy given girl or probability of girl given boy is a probability of boy girl plus probability of girl boy is a one and a half. But in this case, we know that the condition that is a king family, a king. Since it is a king family, so this event will never happen. So it become 1/3 plus 1/3 and equal 2/3. And probability of boy in the king family, given the king family, is a 1 because on the king family once the boy become a king. So what's a probability of two girls in a king family? Yes, as we know, in a king family has at least one boy, so the king only had 2 children, but 2 children are girls, so its probability is 0. So this is all for conditional probability. If you have any questions, please don't hesitate to ask me via the Google Hangout. Thank you.